We've looked at page 117, 118. We did theory of quadratic equations and showed how to draw parabolas, and we did 3 examples on page 118. Now there's another 3 examples on page 119 which we're going to go over and go over each one in detail, but using the same basic theory that we used, or practices that we used before. So first of all, the equation y equals x squared minus 2x minus 1. So we have a term in x squared, and the coefficient of this is 1. So a is greater than 0, the coefficient, so the graph has a smiley face. It's like this. And the first thing we're going to do is calculate the axis of symmetry, which is given by the equation x equals minus b over 2a. And b is minus 2 here, so minus 2. And a is 1. So minus 2 gives us plus 2 over 2 gives us x equal to 1. And so here's the axis of symmetry. This is the equation x equal 1 right here. So 1/2 of the graph here on the left is identical to the other half on the right. One of them is like split right in the middle, and each one is the mirror image of the other. So we found the axis of symmetry. Now to find the x-intercepts, we know along the x-axis that y equals 0. And there's no way, if we set y equal to 0, there's no way we can factor this. So there are no factors of this that are common, so we're going to have to use the quadratic equation to find the x-intercepts. Here's the quadratic equation. And so we're going to substitute. And you can see a is 1, b is minus 2, and c is minus 1. So we've got minus b, which is minus, and then b is minus 2 right here, plus or minus b squared. B is minus 2, so that's this term right here, minus 4ac. A is 1, and c is minus 1. And it's all over 2a, and a is 1. You can see here that a is 1, b is minus 2, and c is minus 1, and we just substituted that over here. So what we get is minus 2 gives me plus 2. Plus or minus is this. Minus 2 squared is 4, and minus 4 times 1 times minus 1 is plus 4. So we have 4 and 4, which is 8, but we're all under the square root of some. So we get 2 plus or minus square root of 8 over 2. Square root of 8 is 2 root 2. And then we're going to factor out 2 from both these terms. Instead of square root of 8, we're going to write 2 root 2. Factor out the 2, and we get 2 times 1 plus or minus root 2 over 2. 2 times root 2 gives us 2 root 2, which is the same as root 8. So this, and then when we cancel the 2 and the 2, we've got 1 plus or minus root 2. And the root of 2 is 1.414, so when we add 1 plus 1.414, we get 2.414, 0. And the other root is 1 minus root 2, the x value. 1 minus 1.414 gives us minus 0.414. So we get the 2 x-intercepts, 2.414, y value, of course, is 0, and minus 414, and the y value being 0. So these are these 2 points right here. 2.4, 0 is this one, and minus 414, 0 is this one over here. So this is your x-intercept, 2 x-intercepts right here. Now, your y-intercept, you have to set x equal to 0. If you set x equal to 0, this is 0 and this is 0, and y becomes minus 1. So the y-intercept is right here. So that's 0, comma, minus 1, because we set x equal to 0, and when we do, y is equal to minus 1, so the ordered pair is 0, minus 1. So we have the x-intercepts, and we have the y-intercept. We have the axis of symmetry, which runs down here, and which was right over here, 1, x equal to 1. So that's this value right here. X is 1 here. Now to calculate the vertex, we calculate again, or we know that the axis of symmetry is 1. We put this into this equation. Y equals, substitute for x, 1 squared minus 2 times 1 is minus 2, and we have the minus 1 here. So we have 1 minus 3, which is minus 2, so the vertex is 1, comma, minus 2, which is right here. And as we said before, because the coefficient of x squared is greater than 0, you can see that right over here. The coefficient is 1, and 1 is greater than 0, so the graph has a smiley face. The vertex is a minimum point. So here's the vertex right here, and it's a minimum point. So we've got the x-intercept, the y-intercept, the vertex, and you see if we connect these points, then we get the shape of the graph. You don't have to get it perfectly, but you need these 1, 2, 3, 4 points in the graph itself, and of course it should be shaped as a smile. Note that the x value of the axis of symmetry, so here the x value of 1 lies halfway between minus 0.4 and 2.4. If we add these two together, we get 2. We divide by 2 to get halfway. It's 1. And that's always a way of checking that the axis of the x value here should be halfway between these two values. Let's go to the next problem, number 5. And number 5 here we have y equals x squared plus 6x plus 9. And in this particular case, again, a is greater than 0, so the graph is a smiley face right here. Coefficient is 1, which is greater than 0, so we know the graph has to be shaped like a smiley face right here. The axis of symmetry, x equals minus b over 2a. b is 6, so minus 6 over 2 times 1, because the value of a is 1. So this is minus 3. So the axis of symmetry is right here. X equals minus 3. 1/2 of the graph is the mirror image of the other half. So now, when we want the x-intercepts, we set y equal to 0, and we get x plus 3 equals 0, and we factor this. First times the first gives me x squared. The inner is plus 3x. The outer is plus 3x. Plus 3x plus 3x gives me plus 6x. Plus 3 times plus 3 gives me plus 9. So we get only one intercept, x equal to minus 3. So we get a point, and you can see it's right here. There's only one intercept here. The graph intercepts the x-axis at x equal to minus 3. Along this line, y is equal to 0, and that's why this is 0. But there's only one intercept in this particular case. Up to now, I think most of our graphs have shown 2 intercepts, but it is possible that a graph, parabola, will only touch the x-axis at one point, and This is an example. The final thing is the vertex. We know that the x value is minus 3 minus b over 2a. That gives us the axis of symmetry, the equation of the axis of symmetry. If we plug minus 3 into this equation, we get 9. Minus 3 squared is 9. Plus 6 times minus 3 is minus 18. Plus 9, this comes out to be 0. Minus 3 comma 0. So that the vertex is the same as the x-intercept. Let's take a look at that. The vertex is right here, and it also happens to be the same as the x-intercept. Now, we didn't, I don't think I did the y-intercept. So to find the y-intercept, we set x equal to 0. And if you do that in this equation, let's take a look at the equation right here. If you set this equal to 0 and this equal to 0, then y equals 9. So the y-intercept is 0, 9. So we have this point and we have that point. And we know it's symmetrical, so it has to be drawn like this. So here, the last example, number 6, the equation is y equals 2x squared minus 8x plus 9. And again, because the coefficient of x squared is positive, number greater than 0, the graph is going to be shaped like a smiley face. We're going to go through the normal steps. The first thing we're going to do is calculate the axis of symmetry. X is equal to minus b over 2a. B is minus 8. I'm just going to take the equation from here. Minus 8 over 2 times a, 2 times 2, which is 4. So we have 8 over 4, which is 2. So the axis of symmetry, x equals 2, is shown right here. There's the axis of symmetry, and one half the graph is the same as the other. To find the x-intercepts, we're going to set y equal to 0. We set y equal to 0. There's no way to factor this so that we get minus 8x. So we're going to use the quadratic formula, and it's minus b plus or minus b squared minus 4ac over 2a. Okay, let's look at this. Minus b is minus 8 because b is minus 8. Plus or minus b squared, and that will be minus 8 squared, which is the same as 8 squared, so it doesn't really matter if we write this like this, minus 8 squared or b squared. Minus 4 times a. What's a? A is the coefficient of x squared. C is this number here, so this is 18. 2 times 9 is 18. 4 times 18 is 72. 8 squared is 64. And when we work this out, we get minus 8. Now, because this is minus 8, you can't take the square root of a negative number. There's no x-intercept here. That's very, very important. There is no x-intercept. So you can see here, although we haven't completed drawing the graph, this graph goes down, but it does not intersect the x-axis. Does not intersect the x-axis. Now, you'll notice that some graphs will cross the x-axis so that there are 2 points. We've also seen a graph where the parabola crosses only at 1 point or touches the x-axis at 1 point. But this is a case where the parabola does not touch the x-axis and there is no x-intercept. If we want the y-intercept, we set x equal to 0. And if we set x equal to 0 right over here, you can see this will be 0, this will be 0, and y will be 9. So we've got the y-intercept here. And we have the axis of symmetry, x equals 2. And we can find finally the vertex once we get the x value. Put this into the equation, 2x squared minus 8x plus 9. And this becomes 4. 2 times 4 is 8. 8 minus 16 is minus 8. 8 plus minus 8 plus 9 equals plus 1. I'll go over that again. Sorry. 2 squared is 4. This is 8. 8 minus 16 gives you minus 8. We add 9, we get plus 1. So the vertex is 2, 1. Here it is. The 2 and the 1, 2, 1. So I have this point and I have this point, and I can connect them. And since this is the vertex, this is a minimum point right here. So we really only have 2 points. And what we could do is we could choose an x value and calculate the corresponding y value from the equation. So we could choose a point that was on the other side here. Let's say we chose x equals 4. If we choose x equals 4 and put it into the equation, we get 2x squared minus 8x plus 9, where x is 4. 4 squared is 16. 2 times 16 is 32. 32 minus 8 times 4 is 32. So we have a plus 32 term here, a minus 32 term here, which cancel to 0, and we're left with plus 9. So when x is 4, y is 9, and that's this point here. Now, one additional note that you might want to make, the difference between 0 and 2 in terms of the x value is 2. So if you go another 2, you come to 4, which should be symmetrical, so that this value and this value should be the same, because this lies halfway between 0 and 4. 2 lies halfway between 0 and 4, and the y should be the same. But you can choose any value of x that you want, and so as you get more points. If you don't have enough values, you can't do other points. But here we're trying to choose a point that shows, first of all, we have this going down to this. We know if this is a minimum because the coefficient of x squared is greater than 0. If this is a minimum, anything on this side should go up. I don't have to choose just 4. I could have chosen 3 and then worked out what that value was. When x is 3, what will y value? But we chose 4 because this is 2 units away from 2, and so the y value should be symmetrical and should be 9. But you can choose any values that you want. So this completes page 119.